quantitative and quantitative methods of University of Milan, and also research fellows at ICRIOS of Bocconi University. Those among you, I'm looking at this side, that already know Lorenzo, like me, I mean, we have been colleagues in Bologna, I've realized, for 15 years. So those who know me are aware of his curriculum and very good papers and research project that he obtained. His main fields, I would say, are industrial organization, industrial economics, economics of innovation, in particular economics of science. Lorenzo also has good expertise and interest in network analysis instruments, and also in tourism economics. And I don't know, Lorenzo, if I'm right, this paper belongs to the tourism economics field. Though you will soon realize that the paper is going to present today is a paper about an issue which, I mean, respectively from our interest in tourism economics, is very relevant to us, because it has to do with booking and accommodation for holiday and getting worried about weather forecasting doing this booking. Okay, so it is an issue that is of general interest. And apart from that, I already had the opportunity to hear earlier version of this paper when I was in Nena. That's really funny. And the paper is really terrific in terms of the theoretical background. The data set, which has been assembled, you will see in a while through a terrific work of data scrapping, is also very interesting. And yeah, overall the paper is very nice and interesting, and I'm sure you're going to enjoy it. Okay, having said that, Lorenzo, the rules of the game are the following. You're going to have 1 hour time maximum. That is, if you finish before that's fine. I'm going to collect questions from the floor and also from the YouTube. So if the question from the YouTube, please raise your hands during the presentation, providing these are spotlight question, right? So question of clarifications, not question that I'm gonna interrupt the flow of presentation. And this more extended question might follow soon after the presentation. We're gonna have another extra hour for, you know, more extended debated questions. The last thing that I have to say to people connected via Zoom is that we are recording the seminar/webinar, and this means that if some of the attendees is not happy about being recorded, it can leave the Zoom and enjoy the broadcasting of the seminar that we're going to have on our YouTube channel. Okay, so if you don't want to be recorded, you can follow the seminar on the YouTube. Having said that, I leave the word to Lorenzo. Lorenzo, please, the floor is yours.
Okay, so thank you. So thank you, Sandro, for the nice words presenting me. So it's really a pleasure for me to be here. It's the first time in L'Aquila, and so it's actually since quite a long time that I'm not giving a seminar in present. So it's really cool. So this paper is entitled "Booking in the Rain: Testing the impact of public information on prices." As Sandra said, these prices are hotel prices. So this paper is across industrial organization, industrial economics, and tourism economics. And it's joint work with Paolo Figini and Simona Cicognani. Paolo is University of Bologna, where I worked until January. And Simona Cicognani, who also used to be at University of Bologna while starting this project, now is University of Utrecht. So let me start with the motivation of this work. By the way, I tried to avoid motivation taken from Italian tourist destinations, but there are a lot of them. So if you are, probably you are aware of this Italian term, which is meteoterrorismo. You can find, I mean, the English translation sounds very strange, meth terrorism or something like this. Is actually is not very used in English, but the idea is something which is much more general than an Italian story. So for that reason, I took as an example for the UK, and well, the source is quite popular, is the Sun. And here you can find an article, a title of an article in which destination managers in Bournemouth are actually very critical of the weather forecast by the BBC that were forecasting bad weather. Instead, the weather turned out to be quite good, at least for British standards. And of course, this is in the view of the destination, is causing losses in terms of visitors and then money. By the way, if you think about well, weather forecast and the concern that people have on their accuracy, I just discovered there is a sort of full industry on the web of jokes about how bad weather forecasts are. Okay, here is just an image of a selection of them. More seriously, so what then is the motivation of this work? Well, of course, the first motivation is that weather, being more general, weather conditions matter in tourism and beyond. Of course, they matter in tourism because all the activities that are outdoor typically are better experienced by tourists when there are good weather conditions. And there is a literature on just showing that if you look at, for instance, at the number of visitors in destinations, they are clearly affected, positively affected by good weather condition. Of course, this can be generalized to other industries, other sectors as well, like agriculture, which is clearly affected by weather conditions. And this something which is getting more and more relevant with climate change. Of course, extreme weather events may cause significant economic costs. And finally, weather is also relevant on the psychological point of view. There is some economic literature showing that, for instance, the weather conditions affect the stock markets because they affect the attitude of the investors. If weather conditions are important, then weather forecasts are in principle a valuable source of information, okay, which should affect economic behavior. In our case of tourism, of course, tourists may decide to book or not for a holiday, depending on the weather forecast, is what destination managers typically think of. At the same time, firms and public authorities can try to implement actions in order to prevent the damages. For instance, if you are organizing an event outdoor, you may think of canceling the event. Sometimes this happens, or move the event indoor. If you take the perspective of an economist, well, in the case in which the action which is affected by the weather is part of a market, okay, we should expect information like weather forecast to have an impact on prices. So we know that prices in markets should convey the information, okay, which is both the private information, but also the public information, like weather forecast. So in the case of tourism, we should expect weather forecast to have an impact on prices of tourist firms, in particular of hotel, which are the firms we are going to talk about, even if the argument can be extended to other firms which are related to tourism. And the channel here is pretty much clear in the sense that weather forecast is information which is relevant for demand. And so having an impact on demand, we should expect the weather forecast to have an impact on equilibrium prices. And so firms should try to respond to information because demand is affected. And an important point, which is, I think, useful for our work, is that in the case of weather forecast, we are talking about an information which is produced at a very high frequency. So we have a lot of information. I mean, tourists and have a lot of information available, and the channel through which information has an impact is clear, and also you can measure accuracy in principle. So given this background, what are the research questions we are asking in this paper? First of all, we ask a very simple question. Do we observe an effect? Are weather forecasts having an impact on hotel prices or not? The second question is a qualification of the first one, is the following. Is the impact that we observe related to the value of information for customers? And in order to answer to this second question, I'm going to develop a simple theoretical model just based on Bayesian learning, just to make some predictions. And the third question is related to firms' behavior, and is actually the question from which we can also derive some implications at the destination level. And are firms adjusting their prices as they should? In a sense here, the issue is the following. On one end, okay, the traditional theory is that since there is an impact on demand, we should expect an impact on prices. At the same time, if you think of the business realities in industrialized tourism, more and more for firms, firms have access to sophisticated revenue management tools, okay, in which they can use the information, elaborate the information, pass data, and so they can produce, they can apply what is known as dynamic pricing in a kind of very extensive way. So dynamic pricing has been around for quite a lot of time in industries like the airlines. So we are all used to observe dynamic pricing in airlines, but more and more is common in other industries as well. And let's say that now there are the ICT tools in order to implement this also for firms like hotels. On the other hand, so in a sense, we should expect a quite significant variation in prices, exactly because the weather forecast information is should be important. On the other hand, there has been let's say a recent literature, which in a sense is elaborating on ideas that has been quite widespread in economics. Literature that is normally known as behavioral industrial organization, which is suggesting that actually firms are less sophisticated in pricing that you could predict in the traditional models. Just to make an example, the paper by Della Vigna and Jenskov, which is mentioned here, is showing that using a case of a supermarket chain in the US, is showing that actually the firm is actually losing money because of not doing price discrimination as they could do. Okay, so the idea that actually prices are too uniform that they should in order to maximize profits. And they have a number of arguments that are related to cognitive limitations, problem of managerial attention, that in principle could also apply to our case. So in a sense, it's interesting to see if there is, for instance, and the answer is yes, and heterogeneity across firms in that dimension. So just to have in a single slide a short anticipation of what we are going to see in the rest of the talk. So I will spend some words developing the theoretical model and the testable implications of the model. And then I will move to data. So the data we are analyzing are data from a destination like Rimini for the summer period. So we can call this a sea and sun destination. I mean, Rimini is also now has diversified a lot, but in this period of time, clearly the vast majority of tourists are there for the sea and the sun. And so we have data, we collected data about hotel prices using as a source booking.com, weather forecast, and a bunch of other controls. And basically the three results we find is that there is a significant impact of weather forecast on hotel prices. So the effect is there and in direction we could expect. Also good weather has an impact of a positive impact on prices. And the magnitude of the effect is actually consistent with the value, the plausible value of information for consumers. So in a sense, this can be interpreted as saying that consumers are broadly quite good in understanding how valuable should be the information they look at the weather forecast. And when they look at the weather forecast, and so the impact of prices is reflecting that. And the answer to the third question is that the response to weather forecast is different across hotels and is larger for upper scale hotels, which means 4-star and 5-star hotels. Well, it's basically 4-star because there is only one 5-star hotel in Rimini. And the interpretation we assign to this result is that 4-star hotels are more likely to have those pricing capabilities that are required to use revenue management techniques. And in that respect, this is something that the literature is suggesting. So let me go to the theory then. So what we do here, first we analyze a simple model in which firms can use flexible prices. So we assume that actually firms can change their prices conditional on weather forecast. And later on, I will compare the result of this model with the result of a model in which there is no such possibility for the firm. And so we are going to derive another implication from that comparison. So in the market, there are a set of consumers and a single firm acting as a monopolist. By the way, this assumption is not restrictive. In a sense, we also work with models with some form of competition. The results are not affected. And the intuition is that the weather forecast is a piece of information which is typically affecting all the firms in the same direction. So at the end of the day, for our purposes, the ruling out the role of competition is inconsequential for our hypothesis. So we assume that consumers are heterogeneous in their willingness to pay for the product, say for the holiday. And the willingness to pay depends also on external conditions, so which is the weather in our case. So these are, we think of tourism as a good of exogenous quality in the definition provided by Candela and Cellini. So there are external conditions, so not under the control of the firm, which is affecting the quality of the service provided by the firm. And weather forecasts are observed by firms and the consumers. So there is a symmetry between the two sides of the market. So we are not in a situation of asymmetric information. And the firm can do pricing contingent to the weather forecast. Okay. And consumers make their choice observing the posted price by the firm and the weather forecast. So more formally, theta is the willingness to pay of the consumer, which is distributed between lower value and higher value. And this is the willingness to pay in a good state, okay? And when the weather is, so good state means good weather. When the weather is bad, there is a reduction in the willingness to pay because the willingness to pay of the consumer is theta multiplied by the parameter alpha, which is lower or equal than 1. So alpha means capture how weather is important for that destination, okay? In some cases, for Rimini, clearly is important. In other cases, it may be less important. So, no, alpha is not consumer specific. So all the specificities are captured by theta. So the idea is that the amount of the reduction is, in relative terms, is the same for all the consumers. So is proportional. So P is the market price. Okay, so the consumer utility function is very simple. Is the willingness to pay theta minus the price when the weather is good, and if the weather is bad, is alpha times theta minus P. And consumer reservation utility. So the utility, if they do not buy, is 0. So the idea that the consumer is buying the holiday only if the expected utility is positive. So let me say a few words and on the important part, I would say, of the model, which is the information that individuals have. First of all, the consumers have access to 2 pieces of information. The first one is the ex-ante probability of a good state, which is R, okay? So in terms of interpretation, this is, say, the probability that the weather is good or bad in a specific season, okay? So the ex-ante is the ex-ante likelihood of the good state. Okay, of course, they would be typically different in summertime, in July and August, or June and September. This is something we are going to exploit. In addition, consumers have information about, can have access to the weather forecast. And this is a signal, okay, that consumers can have. And the signal is correct with the probability Q, which is between 1/2 and 1. So Q equal to 1/2 would basically means that weather forecasts are not informative at all. So it just means that, for instance, there is no weather forecast. Q equal close to 1 means that they are very precise. And notice that here, for simplicity, we do not assume that the signal precision is symmetric between the 2 states. So it's not depending on the state of which is forecasted. And how consumers use this information? Well, we assume that they are rational in the sense they use the bias rule. Here, I don't have the formula. I don't want to bother with the formula of the bias rule in this case, but all the intuition is that you update the ex-ante probability using the signal. So of course, your posterior probability of good weather depends on both, on the precision of the signal and on the ex-ante probability. Of course, if only the signal has a precision of 1, you can be sure that what is going to be the weather state. Okay. So in terms of notation, so GMB means state, and while we have also, of course, prices are a function of the signals, not of the true state, because the true state is not observed until the very end. So the consumer is buying only having observed the signal, not the true state. So the price is contingent to the signal. This is the only slide with some math, just but if you are not particularly interested, it really doesn't matter. But the idea is very simple. What you, after using the signal, you can compute expected utility. Okay, because you have more information about the states of the world. And so if the expected utility is positive, you buy. If the expected utility is negative, you don't buy. And in this way, we can define a threshold in the value of the willingness to pay, theta. So if your willingness to pay is high enough, okay, given the information you have access to, you can, then you buy. If not, you don't buy. And so these thresholds, these two thresholds, of course, you have two thresholds because the thresholds are contingent to the signal. Okay, so you have, depending on the signal, some consumers will buy or not. And of course, as is quite intuitive, more consumers will buy after a good signal. Okay, not in general, not all consumers, because it is also depending on the price. And so the demand functions then are given by the fraction of consumers that are buying, the number of consumers which are buying in the two states, okay? Which of course depends on the information and depend on the price. So it turns out that all the assumptions we made leads to a very simple set of two linear demand functions that you can read at the end, okay? So theta over bar is the maximum willingness to pay. So you have linear demand functions, and the slope of these functions are determined by the coefficient beta, and beta is affected by the information. So the idea is that the demand function is affecting the elasticity of demand with respect to prices. So beta is function of the relevant parameters of the model, which are, I repeat, the ex-ante probability of good or bad state, and the precisions of the signals, and alpha, which is the amount of reduction due to bad state. Yes.
Yeah, just a quick one. Does demand depend on what is on offer? So, for instance, the fact that the weather can complement or substitute some of the things that are offered by a given hotel. For instance, a solarium is badly affected by bad weather. A swimming pool is badly affected by bad weather. A fantastic restaurant is maybe positively affected by bad weather because you can eat more and don't feel like saturated because of the heat, for instance.
Yeah. Well, that's no, it's a very good point. Let's say that all the factors you are mentioning are in the model captured by the parameter alpha. So the idea is that if you are offering services that make the utility of the you can get high even in the bad state, okay, then alpha will be close to 1. In a sense, this type of services are acting as a form of insurance for the tourist. So in that case, if the closer alpha is to 1, the less the weather is relevant. So if I understand correctly your point, the idea that the hotels can make offers in their such that actually the weather is less important. So that's of course the idea is that in any case the utility with good weather is not lower. So it's not, consumers prefer the good weather. Let's say at the extreme they can be indifferent. Okay. So the supply side, the firm is operating at zero marginal cost and zero fixed cost, so it's actually maximizing revenues, and is choosing the price in order to the two prices in order to maximize revenues after observing the signal. Okay, So conditional on the signals, the problem of maximization is very simple. So it's price times demand that we computed before. And so it turns out that there are equilibrium prices, which can be easily defined as a function of beta. So beta is the slope of the two linear demand functions. So this is just a straightforward applications of the elasticity rule. And so these are the values of beta as clearly, well, let's say that I will mention this in a moment about the comparison of the two prices. So we can then compute the equilibrium profit, okay? And there is two properties that I want to stress. In a sense, the paper is, let's say that is, we are not stressing too much the normative implications apart from the very end. But there are two results I want to stress here. The first result is that given our assumption, the level of demand is the same in the both states, okay? Well, this is the fact that it's exactly the same depends on some of the specific assumption. But the idea here is that since prices can be contingent on weather forecast, the firm has the incentive to act on the price in order to reduce the impact on demand. Okay, so of course, when the weather is the signal is suggesting bad weather, well, then consumers become more, the demand is more elastic, so firms have the incentive to reduce the price. So in order to mitigate impact on demand. So at the end of the day, using the prices is a way for the firm to mitigate the negative effect working on the demand side. And the second result is if you look at expected profits, I mean expected before the signal is observed. So in a previous, in a state zero, let's say. Well, it turns out that expected profits are independent of the level of accuracy. So the expected profit do not depend on Q, okay? And the intuition is that actually, since prices can be contingent on the information, so there is no asymmetry between firms and consumers. And at the end of the day, if the accuracy, of course, this is an important assumption, is common knowledge. So all consumers and the firm knows the value of Q, it turns out that prices can adjust in a way that expected profits is not depending on Q. Of course, it's depending on R and alpha. So it's just depending on the probability that the good the weather is good or bad. Okay. Notice that this result is no longer holding if the firm cannot make the price contingent on the signal. And this is a result I will mention in a moment. So if there is an asymmetry between the firm and the consumer, because the firm is not able to adjust the price, in that case, accuracy has a negative impact on the firm because it's making consumer more informed. And I will be back to these results in the last slide because I think it can tell something about the implications at the destination level. So what about the testable implications? Well, what we do is very simple. We compare the two prices, the price when the signal is good and the price when the signal is bad. So we look at the absolute difference and the percentage difference. This is just the formula. And so what we do, we try to see what are the implications on this we can take out of these formulas. Well, the first proposition is that both the absolute difference and the percentage difference are positive. So by the way, this is different, the difference between the price in the good state minus the price in the bad state, okay? So they are both positive. So you should have a positive impact, this is proposition one, a positive impact of forecast of good weather on price, both in absolute and percentage terms. The other two propositions look at the impact of Q and R in this setting. For proposition 2 is the impact of Q, so it's the level of accuracy. And so the idea is that the more accurate the weather forecast, the larger should be the impact of a good weather forecast on the price. Of course, because this means that the signal is more informative, so you should have a stronger impact. Proposition 3 is maybe a little bit more, is less obvious or less evident, is the idea that the higher is the ex-ante level of weather uncertainty, the larger should be the impact of good weather forecast. So how we can measure the ex-ante level of weather uncertainty? By the way, what we assume, and this is somewhat motivated by the data, is that R, the probability of good state, is higher than 1/2. Okay, so it's more likely that the weather is good than is bad. Okay, which makes sense for our application. This is just to simplify the model, so it's not really relevant. Yeah, let's say that is really motivated by the application, but theoretical is not really. It's just making simpler the analysis. But let's say that given this assumption, the lower is the value of R, so the closer R is to 1/2, the more there is ex-ante uncertainty. Okay, because R 1/2 means that it can be equally likely that the two states are good, or the state is good or bad. And so the higher is the weather uncertainty. So in that case, the more it turns out that the weather forecast is actually more informative, because if there is a lot of uncertainty ex ante, observing the signal is more important. Okay, while if there is not a lot of uncertainty, so if R is very close to 1, instead the level of the quantity of information which is implied by the signal is less. Last point is about the comparison of flexible versus inflexible prices. So the idea that, of course, we can assume that firms can make price contingent to weather signals, but you may argue that for firms, doing this may be not so obvious. Why? Because you need ICT skills, you need the ability to elaborate on data, you need people that are aware of management techniques. So there are a number of reasons why you may not use flexible prices. So in the paper in 2016, I actually considered the case of inflexible prices, where this means that actually the price is not contingent to the weather forecast. So the price is decided before the weather forecast is observed by consumers. So actually the firm, if rational, it can only maximize the expected profits given the probability that the consumer is going to observe a certain signal or not. And so here is the expected profit. Well, it turns out that using flexible prices has an impact on profit, okay, a positive impact on profit. So flexibility has a value, of course, has a value because you are using information. And in a context where the other part of the market is more informed than you are if you don't make the price contingent. So unless the signal is not informative, there is a value for flexibility, and the value is increasing in the willingness to pay of consumers, in particular on theta over bar, which is the upper bound of the willingness to pay. And so clearly the intuition is that the higher is the consumer's willingness to pay, so the more important is to be informed. So this is something, so is our fourth proposition that also we can, as you are going to see in a moment, you can test in the data. Okay, so let me move then to the empirical analysis. So what are the data we collected? So the data are from Rimini, season 2015, okay? I guess that most of you knows about Rimini. Probably I think it's very difficult to find Italians that have not been to Rimini at least once. So it's a very important sea and sun destination, more than 2 million arrivals per year. So we are really talking about big numbers. So what we do, we collected information through scraping on 3 types of data. First type of data is weather forecast. And actually we take data from ilmeteo.it, okay? So which is the most popular weather website and commercial website in Italy. And we also collected data on actual weather conditions, okay? From the Aeronautica Militare, so which is collecting the public archive on actual weather conditions. Actually, I'm not going to show you any result concerning that. In the paper, we have a brief discussion of using actual weather in terms of the impact that we can estimate from our model. And finally, we have data about hotel prices and other characteristics of the hotel posted on booking.com. Okay. Notice that we have a little bit less than 900 hotels in our sample, so it's really the big number. So considering that the number of hotels in Rimini is just a little below 1,000, so just is not the population, but is pretty much high. So about the weather forecast, so the type of data we can collect. First of all, there are some data we have data on the minimum temperature, maximal temperature that are provided. And we are using this as for controls. But our main focus will be on weather forecast icons that are used on the website. And I will, in the next slide, I will show you how these are defined, but basically are 8 levels corresponding to sun, rain, and so on and so forth. Okay, so are 8 levels that we can somewhat order, and these are the icons that you can find on the website. And the information about weather forecast are collected from 15 days in advance to the day of arrival at the hotel up to the last day. Okay, so we have 15 weather forecasts for a specific day of arrival in the hotel. And notice that we are going to collect the same information about prices. So prices and weather forecast are at the same date. So this is just the scheme. There are 8 levels from hot and sunny up to shower. By the way, here there is what can be considered a likely ordering of this icons and classification. So the first one should be clearly the best weather. When you go down this ranking, in some cases, you maybe not obvious that one is better than the other. So this is the reason why what we do for most of the analysis is to introduce 7 dummies. Okay, so we have the hot and sunny state as a reference category. So we can compare all the other icons, all the other state with hot and sunny. And so we are going to see actually that the magnitude of the coefficient is suggesting that, so the one you can see here is not the ranking in the perception, at least if you look at the impact on prices.
Lorenzo,
yes,
it's just a curiosity. These forecast icons usually have a probability below them, right?
Yes, we didn't collect the information.
I'm wondering whether, for example, in order to have odd and sunny, you want to have at least 50% of probability for that state. You know what I mean?
Yeah, let's say that, so typically what this information is that the visual information that you see on the website. So I think we didn't collect, and for sure we are not using the information which is somewhat behind that. So the idea that this is the perception, if you, as a consumer, you go there, you can find these icons. While the things that we used and we collected are some information about the temperature. That is clearly, I mean, it's not the same thing, of course. It's something that we also use as a control. So this is about instead the hotel's data. I'm showing this data because then in a while I'm going to not to impose you the full table of regressive, otherwise you cannot see the results. So I just showing you the result for weather forecast, but just to give you an idea that we use a bunch of controls in our regressions that are the variables you can find in the descriptive statistics. Of course, we have here information about prices. So what we do, we ask on booking.com for two types of holidays starting in a given date. The first one is a 1 week holiday, okay, 7 days. And the other one is a weekend from Fridays to Sunday. Okay, so we have these two types of searches on the done. So the total price is the amount of money spent, and the daily price is the total amount spent divided by the number of days. Okay. Yeah.
How is it possible you have 0 as a daily price of booking?
Oh, I was just noting that is something that is, I think is, I just realized now when I was reading, yeah, something that is probably some errors in scraping, so that we didn't realize now. I was just noting when I was looking at the table, I just noticed that there was a 0 that is, of course, is something that is not possible. So then we have, as I said, close to 900 hotel. Then the other controls is, for instance, if the offer is advertised as a special offer or not on the website of booking.com. Then we have a score for the hotel is the excellent, good, that you can find on booking.com, the number of stars. Then we have collected information about the number of available rooms. Just to be clear on that, we don't have data on capacity available at the hotel. Okay, so this is information that we don't have. The information here is the number of rooms that are available on booking.com as they are advertised. So when you go on booking.com, you can find okay, 1 room left, 2 room left, is actually up to 5 room left. Okay, so this is the way in which we can control for capacity, in a sense that we can expect that when the number of rooms available is low, this has a positive impact on prices. Okay, so this is what we can do with the data. We don't have information about the number of real availability at the hotel. And these are other variables. So the basic search was for 2 adults, but we also collected, we did some other search adding 2 kids. Okay, so we also control for that, and we have different length of stay, 2 and 7. We have we control for free cancellation. So if the offer has an option of free cancellation, and board type means full board, half board, breakfast only. And room type is a classification of different type of rooms, like double room, triple room, room with a view. So there is a way of classifying the offers, both for the size and the quality of the hotel, of the room, sorry. So these are room specific variable. Okay. So what is the model we are going to estimate? It's a very simple linear model where on the dependent variable is the price for hotel I for a stay starting at time t, observed tau periods in advance. Okay, and what we have is the as a main variable is the weather forecast. So as I said, in the main model, what we did was to use this different dummies, but we also run other models building dummy variables that we call no rain and sun. So basically no rain, we take a value of 1 if it is the 5 best category, and sun is the best 3. So as a way of it is a dichotomous way of controlling for weather forecast. Okay, that is particularly useful when we run separate regressions, as you are going to see. So how we test? So hypothesis 1 is very simple. It's just we just look at the coefficient of the variable of interest. What about hypothesis 2? So the idea that the impact of weather forecast is stronger, the more accurate is the forecast. Well, there is scientific evidence that forecast accuracy increases the shorter the time lag between the forecast and the day. So what we do here, we run separate regressions for the last 3 days and days from 4 to 15, okay? And we predict that the impact of weather forecast to be stronger in the former case. Of course, we try to control for everything else, so we can expect a higher coefficient in that in the sample in the last 3 days. What about hypothesis 3? The hypothesis 3 is the impact of weather uncertainty. So what we exploit here, and this is something that is also observed in our data, in our sample period in the actual weather, is the period of the year as a good proxy for weather uncertainty. So in July and August, weather uncertainty is lower than in June and September. So again, what we do, we run separate regressions for the 2 periods, and we expect the impact being stronger in, let's say, the low season of June and September. And finally, for hypothesis 4, the idea that the impact of weather forecast on prices is larger, the larger is the willingness to pay of consumers. Well, what we do, we exploit the fact that we have hotels of different categories. So actually the hotels of 5-star and of 4 and 5 stars are typically facing customers with higher willingness to pay. So we can expect that then clearly for them, the value of using revenue management techniques is higher. So we can expect them to make those investments in ICT, human capital, which is needed in order to use that. Okay, and there is evidence of, in a sense of this. And if you talk to small hotels managers, well, if you talk about dynamic prices, well, it's a kind of anecdotal evidence. They typically talk of this as something which is still quite weird or something really outside their perspective. So what we do, again, we run separate regressions for the 4 and 5-star hotels and the 1, 2, and 3-star hotel. We expect a stronger impact on the former. By the way, something that I didn't mention in the controls, we also include hotels fixed effect and room fixed effect. So since we have a lot of observation, so we have also the opportunity to go and check for control for this. So what I'm showing here, I think last 5 minutes or less, Well, in a sense, I have in the backup slides the whole tables, maybe for the discussion, but I think it's just more interesting to show, to see the data that we have from our results. So on the first 4 columns, you have the result for the regressions, both in absolute level, so using the absolute level of prices, and in log, so that are elasticities, these coefficients. And what you, the reference category is good weather. So you find all these coefficients are negative. So it means that there is a significant negative effect on prices. Notice that we do not observe the coefficient to go in a sense monotonously increasing while in absolute term, while we go down the variable list. For instance, the weather forecast 7, which is rain, has a lower impact than cloudy. Okay, one interpretation is that maybe rain can arrive and then maybe that afterwards there is sun. Cloud is something that is worse for people. Apart from that, anyway, the impact is, if you use the hot and sunny category, is always there. And when you do the regression using the dummy variables, you find positive coefficients. Here, the benchmark is, say, rain or not sun. And in this case, sun is higher. Okay, so in that case, is a log regression. So you can interpret this number as an elasticity. So the impact of sun on prices being around 3.6% on the price. Then about the other hypothesis, what we in this case, what we use to simplify the comparison is the dummy variable no rain, but the results are pretty much robust to the other case. And we do regressions for, say, up to 3 days, up more than 4 days. And the way you should read this table is that odd regression, so the first column, the third column, and so on and so forth, are for the up to 3 days observation. And the column next is the same model estimated for more than 3 days. And so what you can find is that actually the coefficient is always larger for the last 3 days. So it seems that the impact on weather forecast is mainly for last day's weather forecast. And the two groups of regressions are a bit different depending on the type of observations we use. So it's a kind of more robustness check discussion here, but the results are pretty much consistent all over the models. And the part, the table below, is instead the comparison across seasons in the first 4 columns, and then for hotels. And what you find here is exactly in line with the hypothesis, in the sense that you find the effect being stronger in the low season and for the 4-star hotel, okay, 4 or 5 stars hotel. So in this sense, the result, the hypotheses are confirmed by the data. And by the way, I don't have time to look at the other controls, but there is nothing particular unexpected there. So let me just go to the conclusions. So the empirical results in this paper is that it seems that weather forecasts have an impact on hotel prices. And the magnitude is reflecting the value of information for consumers. At the same time, hotels are heterogeneous in the way in which they respond to prices. By the way, just a quick remark is that compared to other analyses, it seems that actually hotels in Rimini are changing prices more frequently than in other destinations. So there is work, for instance, work by Claudio Piga on other destinations in Italy and in France and Spain, which actually showing less variations in prices that actually is the case in Rimini for small hotels. So it seems that the hotels in Rimini are already quite sophisticated, but still there is a difference when you compare across categories. So let's say that if we want to take some policy implications from that. In a sense, it seems that connecting the theory and empirical analysis, it seems that actually the best way for firms to manage weather forecast information should be to invest in pricing capabilities. So this is something that the theory suggests. So as a way of mitigating the impact, and in the data there is evidence that actually some firms are less responsive than others. So a good policy could be to try to invest in the human capital and in the technological endowments of firms hotels in order to make them more responsive and to external information more in general when they fix price. What is interesting is that actually what the model suggests is that if you consider more accurate information, so higher value of Q, but firms are not using flexible prices, this is actually worse for firms. So if you provide, I'm mentioning this because one of the typical reaction of destination managers is to provide local weather forecast information. So the idea is they make the national weather forecast channels are making too many errors. What I want to do is to provide local information, say information specific to my destination, which is more accurate. And this should be good for the destination. Well, if this information is correct, so if at the local level you think that actually the information is given to customers is correct, this is good for customers, but because it's making them more informed. But if firms are not reacting to that, this is actually good for the tourists, but not for the hotels. Okay. So in a sense, it's a good thing if you want to provide the service to consumers, but at the same time, you should make your firms more advanced and sophisticated in which the way in which they manage prices. As for limitation, future work extensions, of course, here is the work on a destination holiday. Paolo Figini, in particular, has been collecting data for other destinations, not only seaside destinations, but also cities. And the preliminary regressions are somewhat suggesting what you could expect, that for those destinations in which the weather is less important in terms of tourists, of course, the impact is lower. And of course, this is something that is quite expected, but it's nice to start seeing this in the data. Okay, that's all. Thank you very much.
Thank you. Thank you very much, Lorenzo. You've been very clear and also very effective in the presentation. I like it very much. Now, we're gonna have questions. Usually, I mean, the routine that we have here is starting with PhD students. So if PhD students have questions, I'm gonna start from them. There's already one, and then we pass to the other. Carlo.
Hi, thank you very much for this interesting presentation. I don't work on tourism, but I find this super interesting. And what seems to me is that this could be intended like some sort of modelization of a temporary migration, no? In the sense that you use the utility function to understand the willingness or the elasticity to buy a given service. No, so my question that, I mean, maybe silly, but I try. is whether there is, according to you, a possibility to account for some sort of self-selection, in the sense that since you evaluate the utility function, my point is that there could be the case in which a family or an individual has a fixed period in which to go to holidays. And so the decision is driven only by the availability from his job, basically. And the other point, the other source of possible self-selection is the, how do I know how to say it in English? If an individual is a frequent, is a usual tourist of this kind of, also hotel, you know, also especially in those kind of cities in Emilia-Romagna, that would be also a personal relation between the consumer, the customer. Yes, fidelity, stuff like something like that. So some attachment that goes beyond the amenities or the stuff. And then I'd have a question more related to the work I'm doing now on the Bayesian probability and the conditional probability, but maybe I can send you an email later on, not to bother the others. Thank you.
Thanks a lot. Can you want to reply now, Lorenzo, or do you want to?
Yeah, I mean, so I don't forget about the step selection. Of course, I mean, your point is absolutely correct in the sense that it can be that for some consumers, demand elasticity is pretty low. Of course, here there is an issue that there is maybe competition across destinations, so you may move to other places as well. But let's say that in the data, my way to reply is that we have also run separate regressions for the weekend only, and probably the weekends is less affected by that. So since you have more, so you can maybe move from one weekend to the other. So still we find that the same, this very similar effect. So that was one possibility to answer to your point. About the loyal consumers, here my reply is that here we are using the data from booking.com. So I can expect the loyal consumers are probably booking directly, so they do not pass through to this if they really want to go to a specific place. So in that case, probably these are more consumers that are looking for a good deal, let's say.
Right. So before moving to staff, any other from the PhD side? Francesco.
Thanks for the presentation. I have a question related to the average time period for booking. I mean, I'm a consumer in this research, and I have to decide when I will go on holiday. So the weather forecast is, in a certain sense, not so trustworthy, because I have to booking after a certain period, but I see the weather forecast right now.
Yes.
Did you consider this average time lag between the reservation and the effective days of holiday?
Yes, let's say that we control for what is called the lead time. So the lead time is exactly the time between the moment in which you observe the weather forecast and the price. So you may decide of booking, and the moment in which you leave. So this is something that we control for.
Okay, and also I have a curiosity. Did you consider the Airbnb data? No. Because some informal forms of hosting.
Well, here we don't have only.
Okay, just for future research, because I think that the hotels are more structured. They have also some fixed costs, while the adjustment for an Airbnb or a more informal housing hosting form could reflect better the flexibility of price?
Well, actually, let's say that the evidence that I'm aware of is for Airbnb is actually suggesting that they are more using uniform pricing. So in the sense that, for instance, Airbnb is also providing a service for helping hosts to manage their prices dynamically, but exactly due to the kind of cognitive limits or problem of managerial attention, using these price tools can be complicated. So it's actually, they are less using dynamic pricing than hotels.
Okay.
By the way, it can be that some of these firms on booking.com, they are also on, because you know that there are also some hotels on Airbnb. There are not so many, but you can start finding hotels on Airbnb as well.
Great. I don't know. I can't see from the Zoom. Oh, so there's a question.
Thank you for the presentation. I was wondering if you have included dummy variables or other type of variables, control variables that would be used to control for the origin of the customer or not, in a sense that this may impact most probably the elasticity to prices. For example, as people coming from outside of the local territory may be less impacted by weather.
Yeah. So let's say that the simple answer is no, because we don't have data about the origin. Let's say that we were playing a little bit with some other data on winter destinations, and so in a sample where we have different destinations, in that case you may try to account for the fraction of foreign tourists visiting a place. So you can, of course, you don't know who is booking, but you can know the composition. Clearly, here is only one destination, so we cannot do that.
Thank you for the presentation. Mine is just a curiosity. Just if you think that it could be extended to other cities or other destinations, if you could consider also the effect on prices of people going for events or for work that are not reflected directly in the booking, because maybe for work company do not allow this kind of reservation, but maybe they can affect the prices and it's not directly captured by the weather. Thank you.
Yeah. Actually, what we in the sample that Paolo Figini is working on, there are cities like Milan. So of course, you may, in that case, the type of tourist is different. You can control for events that are occurring. So you can try to exactly to see if the type of effects is heterogeneous depending on these factors.
Right. Thank you. Thank you very much. As far as I know, we have PhD students also connected via Zoom. I can't see what. No, there's Vincenzo Fasone, who is not a PhD student. Hi, Vincenzo. But I hope you don't mind if I give priority to PhD students from the Zoom, but I don't see Rai hands. No, there's a message of a chat which I can't see. Oh, there are no questions. Okay. And also Gloria sent me, Gloria Cicerone is following on YouTube, and I thank you here for that, saying that no question. So we can start. I mean, it's not implies that PhD students can't pose question anymore. I mean, you can pose any time, right? It's not that your time is dead. You can follow up later on. But now let's open also to faculty. Alberto, shall we give priority to Vincenzo, please go ahead.
Yes, thanks, Sandro. Definitely, I'm not a PhD student, but thanks to Lorenzo for your kind presentation. Just a very quick and general question or consideration, if you want, about seasonality. Looking at the demand side model, I guess you introduce the alpha parameter to take into consideration this aspect or not. What do you think about seasonality in the model? Just to say.
Okay. Well, let's say that the assumption we make in the model is that actually alpha is not depending on the season. Okay. So the idea is that the conditional on the good or the bad state, the reduction is the same. Let's say that in principle, we could have, we think that seasonality should have a stronger impact possibly on theta, on the willingness to pay. And by the way, for us, this is not too problematic because actually the effect of theta is going against our hypothesis when the seasonality is considered. So in a sense that if we find the effect that the weather forecast is stronger in low season, it means that this is counteracting any effect due to the different willingness to pay that we could have. For the alpha, well, let's say that we thought about it, but it's not sure how we should, the kind of prediction for the impact of alpha on seasonality. Let's say if, so why, for instance, in the low season, the reduction due to the bad weather should be stronger or higher than the impact of the bad state, so bad weather in the high season. So it's not, let's say that for sure, I mean, the fact that they're exactly the same is a kind of theoretical assumption, but we don't have a specific a priori on one sign or the other.
Okay,
right.
Sandro, just another thing.
Sure.
About the variables, maybe you can take into consideration if the hotels belongs to an hotel chains or if is an independent hotel, because I think referring to the pricings, the strategies that hotels use, this aspect is very relevant.
Yes. No, that's absolutely an important point. That is a remark that we also received from the reviewers on a certain point. Well, what is quite impressive, I think, because we look at the data. There are data collected on belonging to hotel chains, and in 2015, okay, in all Rimini there were only 15 hotels belonging to an hotel chain. That's very few. So that's for 2015. So in a sense, we could actually go, and because we have the names of the hotels, we can try to cross, but let's say that this effect is very, very limited. Of course, if you do the same exercise for other destinations like Milan or Venice, Rome, of course, in that case, it would be important, because then the number of hotels chains is the fraction of hotels chains of hotels belonging to chains is much higher.
Are you happy with that, Vincenzo? You happy with that? Okay. Okay. Regards to Sicily over there. Now, other question. Alberto, you had a question.
Grazie Lorenzo. It was a very interesting talk. I have a question for two Lorenzos. One, the expert of tourism economics, and the other, the industrial organization dynamics scholar. So I'll start from the last one. And I mean, I know it's not covered potentially in the core of your paper, but I would like to know a little bit more about the, you know, the structure of and the technological aspect of the story, because here obviously we've got like an adoption of technologies which relates to some of them maybe platform technologies related to the forecasting of the demand, the prices, and so on. So we'd like to know how does it go there in that specific sector? Is it like a common platform which is shared among all the actors? So there are specialized suppliers. I mean, it's just a curiosity, but it's interesting because it's like a specific type of platform economics to me. Then I've got a couple of points to the tourism scholar. And basically, one thing that if I got it right, you've got a TAU, which is max 15 days. And so connecting to the points that were raised by Francesco and Carlo, like, I think this has got some implications on your result, because especially for the part July, August, right? So if you got a TAU of 15 days, this is kind of emergency holiday in Rimini, right? I don't know where to go, and I'm going there regardless of the price, regardless of the weather, because otherwise my wife or my husband will basically bother me for the entire year. To come. So what I mean, how does this affect your results? And have you got like at least a small section of results where you have collected data more in advance so that you don't have emergency, I don't know whether it's a correct terminology, but you got my point. Yeah. Okay. Then I think an interesting point of your case is the fact that Rimini, once upon a time, was a sun and sea, I would add fun resort. So sea, fun, and sun. But nowadays it diversified quite a lot. And I don't actually see this point in your results because I think it could affect the demand quite a lot. Like whether you are, I mean, there's obviously lots of arts, food, and all this kind of stuff going on. Family still relevant. And have you got any idea on how this could affect your results?
Well, okay.
That
on
will
the
make
first,
the elasticity to price lower in some respect. That should make elasticity to price low. Yes. Yeah. Precisely. That what I want to. Yeah.
No, that's there are 2 points. On the first point, put in a simple way, what you have are what are called revenue management softwares. So it's softwares that you can use. Well, I mean, they can be of different level of sophistication. In some cases, there are software that are just suggesting you a price, so you don't know what is happening in it. So maybe you just put some data and then there is a price. Of course, if you want, you can use that price which is suggested or not. So that, and there are a lot of them. So of course they can be of different level of, as I said, of sophistication and price. And the second thing is that there is a whole industry of consultants on revenue management. So very frequently, the hotels, what can do, they don't have maybe a revenue manager, so a person working for the company, especially the small ones, but they can ask the support from external experts that are somewhat managing the prices, that are making suggestions. So in a sense, in that case, it's not an adoption in technical terms, but you just externalize this type of service. So the idea is that, of course, there is a cost. In general, there is a cost. It can be a different type, and there is in terms of an issue in terms of knowledge, because of course you know. You must know, for instance, that sometimes maybe the software is suggesting you a price, but you know that there is some other information that you should have an impact that was not. So it's not really easy. So it may be also a problem of lack of knowledge on the hotels on the hotel side. Of course, when you think about chains, chains instead have the software, they have a lot of information because they can collect information. So clearly they are in the best position. About the second question about on the consumers, you're perfectly right. So there may be a good number of customers that are booking well in advance of the last 15 days. So let me put it this way. On one hand, our idea that for those booking very early, weather forecast should be irrelevant. Okay, so of course you have a number of customers for which weather forecast is irrelevant. So in a sense, we're selecting our sample in order to see some effect. Okay, let's say that. Of course, this is, I think, is relevant whenever you want to use our results to estimate the damage or the loss of weather forecast for firms, in a sense that, of course, if you are in a season where a lot of people have booked very early, of course, weather forecast has not really big impact because they book well in advance. Notice that it's a bit tricky because here you may have offers with free cancellations. Okay, so maybe you can book in advance. Okay, well in advance, but if you are somewhat risk averse and you buy the opportunity for a free cancellation, maybe just normally free cancellations can be you can cancel freely up to 2 days, 5 days, it depends. So you can say that if the weather forecast is bad, you prefer to cancel. So in a sense, you should take into account when you estimate. So clearly you cannot use our data just to say, assuming that all consumers are booking in the last 15 days, so that the impact of weather forecast should be multiplied by the number of users. And as for the other observation about Rimini, you are right. Let's say that the problem of, I have two answers here. The problem of, or it's not a problem actually, for Rimini is a good thing, of the diversification story. On one hand, in the 4 months that I'm considering are months in which there are not such a, it's not the month of the very big events in terms of, for instance, of fairs. For instance, the first on tourism, the TTG is in October. Ecomondo was the one on environmental stuff. Is clearly they are put outside the period.
You might have big concerts, for example.
There may be, I mean, still there are fairs. Okay,
Yeah.
there are the fair on what is it called, the one on gym stuff. I don't remember. I'm out of the business of, and that one, for instance, is at the beginning of the summer. Yes, that's clearly that is important. Sorry, you can think that from the destination point of view, you can read this as an attempt of increasing alpha. Okay, so it's an attempt of increasing. So trying to attract tourists for which weather is less important. Okay, of course, this is a perfectly sensible way of managing the problem of weather forecast. So in the model, if alpha is close to 1, so if weather becomes irrelevant, well, of course, all the problems of flexible versus inflexible prices related to weather are not an issue anymore. It would be interesting, my feeling that if we collect data if we have data, but we don't have it. Suppose that you have data maybe for different years or maybe different periods of the year, you can try to see what is the composition of tourists in each period and to see the effect. But your observation is perfectly right. The heterogeneity issue is there.
For instance, if you have like granular enough data, you could, for instance, take out the period, the 15 days before the Technogym fair, for instance, from your data and see whether the results hold. So that you basically exclude this confounding effect from the empirical analysis. So taking it out, for instance.
Well, what we notice that what we have is we have a fixed effect for the check-in date. So we have a variable for each date, because remember that we have a lot of observations, so we can put a lot of controls here. So in a sense, of course, here is a way of controlling. Instead, we could try to create variables in order to see if exactly the effect of the weather forecast is different for different, maybe creating variables for big events. So if you say that for those dates, well, I can expect the weather forecast is less relevant when there are big events, except because people are going there. Note that it's interesting because the same people are very often booking late. So in a sense, they are in the sample. Yeah, they are in the sample, but so we can try to see something here.
Thank you very much. I've seen that Andrea Scani has asked, does Alessandro too?
Oh, maybe Andrea was before. I don't know. Okay. Thank you, Lorenzo. I really enjoyed your presentation. Nice topic and a lot of work in the paper. And before my comments, could you go back to the model slide? Because I lost actually what you use as a treatment. So basically the data WF variable, which are a set of dummies. Could you explain better, please?
The set of dummies, so is one dummy for each weather forecast category. So the weather forecast is this one. Okay. So hot and sunny, blue sky. So we have 8 dummies. Okay. So we put 7. Actually, the misty rain is at a very low frequency, so actually was dropped because of the collinearity issue. So at the end of the day, we have 6 dummies that we estimate the coefficient for, and so we can the result I was showing are the impact with respect to the hot and sunny weather forecast.
Okay, okay, crystal clear. So you basically use the forecast as a treatment, not the actual weather.
No,
right?
Actually, in this regression, actual weather is not used at all.
Okay, so I have one main comment and some suggestions. Maybe. The main point is related to both the demand theory and the empirics. So given that you use just the fixed effect model, the problem I see is that prediction, forecast, whether it basically make price endogenous, because prices adjust over time with weather.
Yes.
So the problem is that you are estimating a demand function that changes over time, and over time may select people who sort in higher or lower prices. And within this setting, you might have also adverse selection, because consider your market as an insurance market, like, for instance, there are some paper by Johan Spinnevin, who studied this topic. So the problem is that if you have heterogeneity in the risk, also prices change because this heterogeneity, adverse selection, typical problem. And I think that this is the same setting as in the case of insurance market, because people consider that you have an exogenous date, okay, in which you book a travel, for instance, 1 month before. In that case, the weather is totally exogenous because you're not able to predict 1 month before. But on the contrary, if you use changing prices because of the weather just the day before, in that case, the sample might be selected. I don't know if I properly explained this concept, but maybe I see this point in your setting. Yeah, but the weather forecast is the treatment. The forecast is the day before or some days before.
Actually, they are simultaneous.
Yeah.
Yes, the weather and the price are the same day.
Yeah, but that's the problem, maybe. Yeah, that might change. Yeah, I don't know, Lorenzo, if this is actually might be a problem, but maybe this is a point you might go through. Maybe we can speak later.
Yeah, that's.
But no, my suggestion is, if this is the setting, if I well understood, maybe you might use a distance indicator or something like that to capture the exogenous part, for instance, as an instrument, or just in a simple fixed effect model, to capture the exogeneity between the prediction and the actual weather. So this is a really exogenous change in weather. And maybe you might use that change as a treatment for the difference between prediction and actual weather.
Okay.
Instead of just forecast. But this is just an idea, okay? Just think
Okay, I need to think about it. So the about this, and then talking with my co-authors that are the more econometrically rated. I think it's no. I think your point. I mean, it's if I in a sense to if I want to it's not actually an answer to your point, but it is an issue that clearly we have here, is that clearly consumers may be also strategic in the way in which, for example, they can wait booking, depend on, they can try to collect more information, so they can, of course here, let's say that in a sense, the issue here that generally speaking, if you think about dynamic pricing, there is also always the trade-off between just waiting and running the risk that capacity is sold out. Okay, let's say that this is something we can control, because we know when the hotels is not offering any price on the booking.com. But that is also an aspect. On the more technical, maybe we can talk later. So on this aspect,
just because it is not something empirics. It is both related to the theory and
no, the theory here. I mean,
no?
the theory here. You said in the model actually, you notice that there is no time, in the sense that the full model that you could have in mind is the idea that the consumer is exogenously allocated to a period in which he may decide if booking or not. That's the model, in the sense that is here. Of course, is ruling out this strategic behavior, or for instance, when there is free cancellation, you can book and knowing that you can collect more information. So the strategic problem is the problem of the consumer is much more sophisticated here. Even if my intuition is that for the predictions that we are testing, probably a more complicated model will not change the prediction in terms of the value of information. So in terms of the accuracy, the impact of accuracy, or the impact of ex-ante uncertainty. Of course, a more sophisticated model could have implications on other aspects.
Then I have a couple of maybe suggestions. Maybe you might use non-refundable bookings to test for more rigid demand.
Sorry, you can repeat?
You can use, if you have data, non-refundable booking.
Yeah.
If you have this information to test for how demand responds to these different, more rigid.
For now, I mean, this is one regressor. So we have is a dummy, the free cancellation.
Okay.
You may think of running separate regression, for instance, on the sample of only non-refundable tariffs.
Or at least add some controls for weekend to distinguish between.
Well, this is something we do. Something we do, because we have these two type of observations, because we collect the data by making searches on booking.com. So so we have observations referring to weekends and to the whole week. So we also run separate regressions for weekends only, and the results are
also because it is related to the previous point between business travel and vacation. No? I think this is very important. And also, maybe you might consider more in depth the indicators, the weather indicators, because people have different beliefs on different icons. So if you see the icon, maybe, I mean, your belief can dramatically change between just an icon and the millimeters of rain it predicts. So maybe you might test using information on millimeters of rain, or whether it is rainy or not, to test if this icon distinction works also in a different setting. And that's it. Thank you very much.
Yeah, on this last point, actually, as I said, we have some data on other predictions like the temperature or the amount of rain. Okay, we run some robustness checks using temperature, and of course here, for instance, there is other research showing that for sea and sun, basically there is no, the effect is monotonic in the sense that people prefer a higher temperature than lower. So the ideal temperature is around 27 degrees. So apart from August, that the central part maybe, or some days in July, maybe of course higher. But we find some basically the similar results. But I think you point out a good point about the interpretation of the icons, in the sense that there is also literature working on perceptions. For instance, I mean, there is all the issue about perception of probability. For instance, there is a nice paper by Gigerenzer, which is the psychologist, is big rival of Kahneman and Tversky, for those who are in behavioral economics stuff. And so there is also an issue of interpretation. Let's say that any type of information you can provide through weather forecast, probability, or icons is subject to problems of interpretation. Let's say that probably in that case would be very interesting to do some experimental work, some asking people to make potential choices, providing them weather information. It could be something as a yeah, of course, yeah, that's absolutely. So there is a significant degree of ambiguity in the way you can interpret the various signals here, and heterogeneity.
Right. Andrea, are you still there? Andrea Scani.
Yes, I am there, but all my questions have been asked already by Alberto and Alessandro.
Can you speak a bit louder? We can't hardly hear you.
I was just saying that all my questions were asked already by Alberto and Alessandro. So I don't know, I can maybe just add a couple of points, but very general at this point. So thanks very much for the presentation, Lorenzo. So I was just thinking that, okay, that there's a very specific dimension to your presentation in terms of the amenities of the location, sun and sea. Okay, maybe it's also a bit diversified, but in summer it's probably what consumers expect to find. They go there mostly for this type of amenities. So amenities and expectations of individuals are very specific. So I was just wondering whether you think that your results and implications or your setting might change for locations with a comparative advantage in different amenities, and where consumers have therefore different expectations in terms of the weather. So that's a very general point. And then I was wondering whether you have data on cancellations, like when consumers actually cancel their bookings, because that would be nice, maybe for a sort of falsification test, but I'm not sure you have this data. Thanks.
So on the first point, actually, I mean, it's clearly, as I was saying before, there is a specificity to the destination in terms of how weather is important. So clearly is a case where, in a sense, is a destination where weather is pretty much important. But I think that is a lot of destinations have this feature. If you think about winter resorts, of course, it's a case where also the weather is highly important. And in addition, there is the issue of the snow. So it's weather is clearly, and there is evidence on that. Maybe just if we're thinking this, going back to one of the previous points, for instance, there is also empirical work showing that what is also important is the weather at the origin. Okay, for instance, if you are in a country, let's say it is kind of year specific. So if you, in your country is a particularly bad season or hot season, you want to go for instance, if you live in Milan, it's a very hot period, you want to go over for a holiday. On the second point about the cancellations, also we don't have data. What I can tell you that I have another project on hotels, looking at the refundable versus non-refundable difference, so the determinants of the cancellation risk premium. And for that project, we're looking at a bit of the literature, and there are very few papers because this type of data are really private information by companies, so it's very difficult to have data. There are some work on that, in particular work but done by Martin Falk, that maybe some of you may know. That is the Austrian guy who is working on innovation, industrial tourism, is publishing in everything, everywhere, and has done work on collecting data on cancellation for the in a Finnish, for like a chain of Finnish hotels. And let's say that actually cancellations are much more frequent if you look at the data, generally speaking, far away from the arrival day. So it's the late cancellations are relatively infrequent. So the number of people that are just canceling before arriving. Notice that, for instance, there is also some evidence, some people that are using cancellation in a strategic way. So they book and then they continue their search looking for the best deal, and then if they find a lower price, they cancel the original booking. So there is evidence, for instance, people that book and they cancel just a few days after. Okay, so let's say that so this is suggesting that probably it's not so frequent that so people cancel at the end, which is probably a type of cancellations you could expect related to weather. Okay, I mean it's but clearly this, I mean the sample I'm talking about is the more distant you can think from Rimini, because it's Finland. So the honest answer is that I don't know about the cancellation rate in that case. Notice that in general, cancellations rate are pretty high. So the at the very early, say late from the early days, they become relatively small, close to the departure.
Right, Andrea, are you happy with that?
Yeah, very happy. Just regarding the first point, now that you ask, I was not explicitly thinking of like winter resort places, but more like places with amenities like museums and these kind of things. I mean, now it's the rainiest season probably in Rome, but there are a lot of tourists, right? Maybe because they don't want to go to the beach. So I was just thinking of places with completely different amenities and expectations regarding the weather. But that's fine.
Yeah, but that for those type of destinations, as I said before, the kind of preliminary analysis that Paolo Fegini is conducting on similar destinations, I think is working on data with Milan and Venice. So Venice pretty much similar to the Rome example you were making before. The result is much smaller, so which is what you can expect. No, for if weather is not important, weather forecast is also less
Well, then
important.
it's, yeah. Right. Any other question? Yes, Andrea.
Thank you very much for your presentation. It was really great. I'm a new student, so for me it has been a great opportunity to see how you work, how you construct the hypothesis, and so I had a curiosity in regards to have you had the opportunity to share this result with the local institution or a trade association specifically to the Rimini contest? And if yes, how they have react to this result? Thank you.
Well, that's a very nice question.
Yeah, this is an excellent question. With to finish, I guess, about the policy implication stuff.
No, let's say this is quite funny because actually we were presenting, I think it's more or less in the same, so was an early version at this before the same period that Sandra was mentioning before. So at the TTG. TTG is the Fair on Tourism. And there was a session organized by, say, University of Bologna and the Research Center on Tourism. And in the audience, there was the president of the Associazione di Albergatori, the hotel owners. Well, actually, the reaction, well, we know that. That was the short reaction. So of course, that's in a sense, which is I can judge this as relatively.
But didn't they react to? I mean, the final point that you made about the need of having flexibility in pricing.
But that's something
that should be.
No, but that's something that actually it was not there at that moment.
It was not there. Okay.
It was not there because actually, in a sense, the progress from the very early version we just ran. It was just the basic regression, and so showing the effect. So basically, it was proposition one, and that's it. So then we further developed the other hypothesis. And so also we work on the differences in heterogeneity. So that part was not there. Of course, maybe that one could be quite interesting. Especially if you think about well, actually in the recovery and resilience plan, there is money for hotels, but it's typically for the buildings, for the improving of the infrastructure. So the suggestion here, in a sense, is really related to the digital side. Okay, that's the idea that you should try to. It's digital and human capital. You may think that, for instance, it would be interesting for if you think about PhD students working with firms, should be interesting to have PhD students doing research in tourism, working in hotels, working on pricing, for instance, maybe more marketing-oriented persons, or even young researchers. Of course, the problem is that clearly here there is an issue which is also cultural, in the sense that, of course, the big hotels and the more maybe managed by younger people are clearly very open to that. I heard sometimes hotel owners saying that so really okay, but I don't want it. For me, the price must be one. So why you should? So that's so in that case in those cases it's really also a cultural dimension. Of course, let's say that maybe if you work like many hotels in Rimini, if you work with the same guest every year, and most of your hotel is booked by the same group of older person coming together, so maybe that the value of doing all this stuff is maybe limited. So maybe in some cases not, but generally speaking, there is value there that you can exploit through building on this capability, let's say.
Great. I think that it was a very relevant point, Davide, and it was good that it came at this stage because I think it looks like a suitable conclusion. And we have nearly, came to the end of our available time. So we thank you a lot, Francesco, Lorenzo. It was an excellent talk. The topic is super interesting, and we do hope that you also bring home something. Okay.
Yeah,
and for that, I thank you, all the attendees and people that were here.
It's
okay?
absolutely great. I mean, 45 minutes or more of discussion is
In
something that you don't normally have. So
in addition to the
it's really great.
yesterday.
Thank you very much for all the comments.
Yeah, and thank you also to the attendees on the Zoom. Thank you, Vincenzo, and thank you to all the others. And in terms of next seminars, do we have already something on the calendar? I can't remember, Luca. December 15 December. Okay, so for the time being, right. Okay, so for the time being, next seminar will be December 15. Okay, but you're gonna receive usual communication about that. Bene. Okay.
Thank you again.